Solid Edge provides industrial machinery and equipment manufacturers with affordable solutions to help transform their product development process and deliver world-class products to customers. This is done using a portfolio of professional, easy-to-use software solutions that help meet customer demands for precision machinery at lower ownership costs, all while staying ahead of competition with lower product development and manufacturing costs. To show this, we'll walk through a day-in-the-life process common to industrial machinery manufacturers utilizing this pick-and-place robot assembly for gear linkages from one of our customers, Maschinenfabrik Grützen. Through this process, we'll see how Solid Edge's portfolio of design, simulation, manufacturing, technical publications, and data management provide a comprehensive solution for creating digital representations of products and manufacturing processes throughout the product development process. The first step in our creation process is to design the assembly. Siemens Solid Edge provides all of the tools needed to create 3D digital models of industrial machines. Whether working with complex part or sheet metal designs, Solid Edge synchronous technology makes creation and editing a breeze. First, we need to finish up our framework. Solid Edge's unique frame creation ability allows us to use this 3D body to define and control our frame members. Using the edges of the body, we can quickly and accurately place the frame sections. And with universal end condition controls and automatic trimming, frame creation is a quick and simple process. Of course, if any last-minute changes are needed, synchronous technology allows us to quickly and accurately make edits without any additional measuring. To finish up, we'll let Solid Edge automate 2D drawing creation based on company standards with a cut list table for the frame sections and automatic ballooning to connect the graphics with the parts list. When it comes to industrial machinery, fast and accurate sheet metal design is a vital process. Whether modeling enclosures, hoppers, or guarding, Solid Edge provides simple and intuitive workflows, allowing for the use of background parts to easily create the sheet metal designs we need. Here, we'll use our background framework to precisely model a guard that protects the electronics from moving parts as well as ensures sufficient airflow for cooling. With our assembly components designed, it's time to define which fasteners we'll use to hold them together. We can leverage Solid Edge's delivered libraries of internationally standardized fasteners, or create a customized library to incorporate our company's own standard and catalog parts. For these bases, we'll simply select all of the bolt holes, select the thread depth, and Solid Edge handles the rest. Since we'll only be looking at the components that fit, building stacks of bolts, nuts, and washers is a simple process. For this, a simple bolt and washer will suffice. And speaking of standardized parts, there are many off-the-shelf products that are used in the design of industrial machines. Solid Edge links with large part communities to give our customers easy access to off-the-shelf components for use in their designs. However, if you've used these components before in previous designs, why go through the process of re-downloading and then replacing them in your assemblies? Solid Edge provides scalable data management solutions to ensure that you have easy access to existing components. Here, we're using Teamcenter, a comprehensive PLM solution to store and manage our design data and processes. We can easily access and search all of our available parts using the intuitive filter options to find the conveyor motor that's right for this assembly. And for those of you who have used complicated data management solutions in the past, notice that we didn't even have to leave the Solid Edge interface. Teamcenter enables us to design machines customized to meet individual customer requirements and regulatory requirements, controlling and documenting engineering change and release to manufacturing. Now we'll use Solid Edge simulation with its underlying Nastran solver to prove our design concept. We need to make sure that this bracket will not fail due to stress. Solid Edge simulation provides the ability to analyze and prevent the possibility of structural failures caused by stress, thermal expansion, buckling, and vibration. And with Solid Edge's flow simulation solution, we can also ensure that heat is dissipated sufficiently. No matter what's being simulated, Solid Edge provides an intuitive, easy-to-use process designed to be run by design engineers. Here, the stress levels in this bracket are well within the limits we specified, and with the automatic creation of a simulation report with images and data directly associated to the study, we can confidently move forward with our design. Another important part of any industrial machinery design process is the creation of wire harnesses for electrical wiring and components. Here, we're using the Siemens electrical schematic tool VESIS. With VESIS, our electrical engineers can create the appropriate wire harness diagrams, depending on what components and connectors we'll be using to support the power and sensor requirements of the machine. The schematics can be exported for Solid Edge to read in and automate the placement of the wires in the correct pin locations. Once the wires and cables are in the assembly, Solid Edge's wire harness routing tools make an easy job of creating paths and bundling the appropriate runs together. Once the routes have been finalized, Solid Edge can then export all appropriate information back to VESIS with the final wire lengths correctly calculated. As is true with all design and manufacturing, keeping cost at a minimum is important. With the rise in material and shipping costs, manufacturers are more cognizant than ever of the need to optimize their part designs. Solid Edge provides users with next-generation modeling abilities, allowing for optimization of parts using generative design. Seeing as this robot assembly will be managing several of these linkages of different shapes and sizes, we'll need to create a special platform to fit them all. Generative design is perfect for parts like this. Simply tell Solid Edge how the part is meant to be used, how much material or what weight you want as an end goal, and it handles the rest. Generative design allows for the creation of optimized, organic parts that meet your desired function and need. When it comes to manufacturing parts such as this, additive manufacturing or 3D printing is the way to go. Solid Edge allows for direct link-ups to desktop 3D printers, or if you don't have access to a 3D printer or require a different material than what's available, Solid Edge can link directly to an additive manufacturing service where we can shop for the type of material, process, and costs needed for the part. From there, we'll simply order it and have it shipped straight to our doorstep. Most industrial machinery components are still manufactured using more traditional machining processes, known as computer-aided manufacturing, or CAM for short. In order to manufacture this table segment, we'll utilize a milling process. Here, Solid Edge CAM operates directly on the 3D model, allowing for intuitive creation of associative toolpaths. Once the full machining process is created, a G-code simulation shows the full operation taking place exactly as it would in the machine shop. This example requires a relatively simple 2.5-axis machining operation, but 3, 4, and even 5-axis machining operations are supported to manufacture more complex components. Now that we've designed our assembly, proven the design concept with simulation studies, and are in the process of manufacturing our parts, we can create the documentation we need to communicate the correct assembly, installation, and maintenance procedures for the machine. Using Solid Edge technical publication software, we can leverage our 3D digital models to clearly communicate how the product should be manufactured, installed, and maintained. For example, assembly instructions for our pick-and-place robot allow for a great interactive experience, helping end users use and maintain their equipment correctly, reducing warranty claims and further ensuring low cost of ownership. As you can see, the Solid Edge portfolio speeds product development for the industrial machinery industry. With rich design solutions, simulation, manufacturing, technical publications, and data management, Solid Edge answers demands for delivering precision machinery to market faster, all while staying ahead of your competition with lower product development and manufacturing costs. To find out more, check out the Solid Edge YouTube channel, or try it out for yourself by downloading a free trial now. Solid Edge, design better.